Alright, good afternoon, everyone. I apologize for not being able to join the meeting because it doesn't seem like my Wi-Fi is allowing me to. Alright, so I'm just going to record a quick video and go over what we were supposed to go over in the meeting today. Alright, so our objectives for today are to explain the commutative, associative, and distributive property of addition and multiplication. And the next objective is to apply the commutative, associative, and distributive properties to break down, let me move this, right, to break down, regroup, and reorder factors to make it easier to multiply two or more factors. So basically, you can use the distributive property, mostly the distributive property, to break down numbers and make it easier to multiply them. Alright. So the commutative property, it's basically, in a sense, it's just saying that the order in which you write the numbers doesn't matter. You're still going to get the same result. So say, for example, we have 4 plus 2. You're going to get the same result if you put the 2 in front and the 4 after. So if you say 2 plus 4, you're still going to get 6. So that's the commutative property of addition. Alright. For multiplication, right here, it says 2 times 6 is equal to 12. So here you have 2 rows of 6 apples, which is the same thing as having 6 rows of 2 apples each. And you're still going to get 12 in total. So the commutative property means that you can swap the numbers. The order in which you write the numbers does not matter. Now the commutative property only works for two operations, addition and multiplication, not subtraction and division. So just remember that. Alright, the associative property, it just means associative, it comes from the word associate or group, right? So it just means the numbers that you group does not matter. The numbers that you group will not change the result, basically. Alright. So grouping is done by using parentheses, and we know from when we were talking about order of operations, we know that the P in PEMDAS means parentheses or brackets. So grouping is done by using brackets to group numbers, right? Alright, for example, let's say we have in brackets 3 times 2 times 2. So all of this now would give you, let me circle it. All of this would give you 6, and that would be 6 times 2, which is 12. Now, if we were to move the brackets a little further to the right and group the 2 times 2 instead. So if we were to put the brackets around the 2 times 2 instead, which is written right here, you're going to get 3 times 2 times 2 in brackets. Now, 2 times 2, as we know, is 4, so it's saying 3 times 4, which gives you back 12. So the associative property just means that wherever you put the brackets, when you're multiplying 3 or more numbers, it does not matter where you put the brackets. Alright. How about addition? Now, just like the commutative property, the only operations that the associative property works with is addition or multiplication. So in this example now, we have 3 plus 2 plus 1. Alright, we know that 3 plus 2 gives you 5, and 5 plus 1 gives you 6. Now, if we were to move the brackets a little further to the right and group the 2 plus 1 instead, you're going to put the brackets around these two instead. You're going to get 3. 2 plus 1 gives you 3, so that's saying 3 plus 3, which gives you 6. It gives you back the same answer. So the associative property just means that wherever you put the brackets, whichever numbers you put the brackets around won't change the answer or the result. Alright, the distributive property. This is the most useful property out of the 3 properties: commutative, associative, and distributive. The distributive property is the most useful. Why? Because you can use it to break down numbers and multiply them much easier. Alright, in this example now, we have 4 times 7. So we can break up 7 into 5 plus 2. So we can break up 7 into a sum of 2 numbers, just like what it's saying here. So according to the distributive property, Multiplying the sum of two or more addends by a number will give the same result as multiplying each addend individually by the number and then adding the products together. So the 2 and 5 are addends. Anything that is being added, they're called addends with this term right here. Alright, so you can break up 7 into a sum of two numbers. You can break it up into 5 plus 2. So when you do that now, you're going to say 4 times 5. So let me draw an arrow here. Then you're going to say 4 plus 4 times 2, which is already written here. So you're multiplying the 4 by everything inside of the brackets individually. Then you're going to multiply both of them by 4. Then you add the products. You're going to get 20 plus 8 to get 28. And according to our multiplication table, or our times table, we know that 7 times 4 is indeed 28. Alright, here's another example. So let's say we're asked to multiply 3 times 2 plus 3 in brackets. Now here we have two blue blocks plus 3 green blocks. And if we have 3 of these, 1, 2, 3 times, or 3 rows of these, you're going to get the same thing as saying 3 times 2 blue blocks plus 3 times 3 green blocks. So you should get, so 3 times 2 is 6. And that's going to be plus, let me try to, okay. So that's saying 3 times 3, which would give you 9. Then 6 plus 9 would give you the same 15. And we're going to test to see if we get the same thing. If we didn't use the distributive property. Sorry, if we use the distributive property, that's what I meant to say. Alright, so 3 times 2 plus 3. Wait, what did I say before? I meant if you do not use the distributive property, if you would get the same thing, because we already used the distributive property by multiplying 3 by everything inside of the bracket. So we multiplied 3 times 2, which is over here, and we multiplied 3 times 3. And we added the products to get 6 plus 9, which is 15. So if we were just to add up everything here, let's see if we would get the same thing. Alright, so it's 3. And then in brackets you have 2 plus 3, which would give you 5. So it's 3 times 5, which would give you 15. And we got back the same answer as if we didn't use as if we weren't using the distributive property. We get back the same 15. So the distributive property would make more sense if you're working with bigger numbers. But in this case, we're working with small numbers. So it wouldn't really make sense to use a distributive property, but it's just an example. Alright, similar to the operation before, or addition, the distributive property can also be used when you're working with the difference of two numbers in brackets. So say for example, you're asked to find 5 in brackets 9 minus 6. So you distribute the 5, or you share up the 5, because the word distributive comes from the word distribute, which means to share or to split up into parts. Alright, so we split up the 5 and we multiply it by 9, which is over here. Then remember we have a subtraction sign, so the subtraction sign remains. Then you have 5 times 6, which is over here. And when you do that, you're going to get 45 minus 30, which gives you 15. Now, the only difference between this and the example that we did before is the minus sign. So since we have a difference of two numbers, we're going to subtract instead of add. That's the only difference. And you should get back the same thing as if you didn't use the distributive property. So that's going to be, alright, 9 minus 6 gives you 3. So it's going to be 5 times 3, which gives you 15. And you get back the same answer. So we know that the distributive property works. Alright, another example. When you're using the distributive property to multiply numbers, what you're going to do, you're going to take the bigger number and you're going to write it in expanded form. So say, for example, we're asked to multiply 7 times 13. 13 is the bigger number, so I'm only going to split up that in expanded form. So I'm going to write it as the sum of two numbers. Remember, it's two numbers. I would prefer if you use two numbers instead of 3 or 4 or more than 2. So I can write 3 in expanded form as 1 tens and 3 ones, or 10 plus 3. So that means I am going to use the distributive property to find the answer for this. So it's going to be 7 times 10 plus 7 times 3. So I'm going to write that there. 7 times 10 plus 7 times 3. So basically you're multiplying what is on the inside of the brackets by what is on the outside, which is the 7, or what is being multiplied. And you're going to get 70 plus, that's what, 7 threes is 21. Then you're going to get 91. That looks like it. Alright, I'm going to use my calculator to double check if as a matter of fact, I'm just going to do long multiplication. Let me do that instead. So 13 times 7 should give you 91. So I'm going to use regular multiplication to see if I get back the same answer as if I were to use the distributive property. So I have 1, carry the 2. That's 7 times 1 plus 2, 91. And we know that the distributive property works. Alright, I had 2 more examples here, but I'm sure you get the general idea. So, just like what I said before, you're going to split up the bigger number. So what I like to do, I like to write the smaller number first, then the bigger number. Then I'm going to split up 23 into a sum of 2 numbers. Or even if you want to use a difference of 2 numbers, you can use that too. But I prefer to write it in expanded form as a sum of 2 numbers. So I'm going to say 4 times 20 plus 3. Because I have 2 tens and 3 ones. Then I use the distributive property. So I'm going to say 4 times 20 plus 4 times 3. That's 4 times 20 plus 4 times 3, which gives you 80 plus 12, and that gives you 92. So let's multiply the regular way and see if we get 92. That's 23 times 4. So that's going to be 12, carry the 1. 4 times 2 is 8, plus 1 gives you 92. So we know that the distributive property works. Alright, I think you can do example 3 by yourself. You remember, always use the bigger number as, always write the bigger number as it would be in expanded form. Right, so you have 12 times 82, so I would suggest that you split up the 82 and not the 12. Whichever one is the bigger number, that's the one you split up. And do A to E as well.